Welcome to another episode of Microsoft Knowledge Nuggets on M265 FM. I'm your host, Mirko Peters. Today's topic is one that almost everyone has heard of, but few really understand: ARM templates. Let's start with a simple question. Are you still clicking through the Azure portal to build your environments? We've all been there, but imagine you need to deploy the same setup 10 times. Or worse, you have to rebuild your entire production environment from scratch after something goes wrong. Clicking through every blade and drop down by hand is slow, and it practically guarantees mistakes. It's like building a house room by room without any kind of plan. You'll end up with something that works, but you'll never replicate it exactly the same way twice. By the end of this episode, you'll understand what ARM templates actually are and how they replace all that manual clicking with a reusable blueprint. This is the foundation of modern Azure management, not just a nice-to-know concept. What exactly is Azure Resource Manager? Let's break down the name. Azure Resource Manager, or ARM for short. It sounds like something you install or download. It's not. Actually, ARM is the control layer behind every single action you take in Azure. Every time you click a button in the portal, run a command in PowerShell or the Azure CLI, or make a call through an SDK or a REST API, that request goes through ARM first. It authenticates you. It checks your authorization. Then it routes the request to the right Azure service to create the resource. Here's the thing. Because ARM handles every request the same way, you get consistent results no matter which tool you use. Create a virtual machine through the portal or the CLI. It goes through ARM. The result is the same. No weird inconsistencies. That's powerful when you're working across a team where some people prefer the portal and others prefer the command line. ARM also manages resource groups. Think of a resource group as a folder, a logical container for all the related resources in a project or application. When you deploy a web app, you might have a virtual machine, a storage account, a virtual network, and a database. You put all of those in the same resource group so you can manage them together. Track costs together, and when you're done, delete the whole thing with one action instead of hunting down each individual resource. ARM handles dependencies too. You probably never think about it. If you're creating a virtual machine, it needs a network interface first. That network interface needs a virtual network. ARM figures out that order automatically. It knows which resources depend on others and creates them in the right sequence. You don't have to manage that complexity yourself. ARM just handles it. So ARM is the engine that makes all of this work, but it needs a language, a format it can read. That's where ARM templates come in. Infrastructure as code, the big idea. Welcome back to M365 FM for another knowledge nugget. I'm Mirko Peters, and today we're breaking down the big idea behind ARM templates. These are the language Azure Resource Manager uses to understand what you want to deploy. Before we dive into the template structure, let's talk about the bigger idea: infrastructure as code, or IAC. Infrastructure as code is exactly what it sounds like. Instead of clicking around in a portal or typing one-off commands, you manage everything through code. You write down what you want, your servers, networks, storage, in a file, hand it to Azure, and it builds it all for you. Simple, right? That's the core concept. Now, there are two ways to approach this. The first is imperative, the old way where you give step-by-step instructions. First create this resource, then that one, then connect them. It's like telling a contractor exactly how to build a house. Pour the foundation here, frame the walls there, add the roof last. Miss a step or do them in the wrong order and things break. The second approach is declarative, and that's what ARM templates use. Instead of telling Azure how to build something, you just describe what you want the end result to look like. You hand over the blueprint and say, I want a virtual machine with this much memory connected to this network with this storage attached. Then Azure figures out the rest: the order, the dependencies, the configuration, while you just describe the final state. And these benefits are worth talking about. First, repeatability. You can deploy the exact same environment 100 times and it will be identical every single time. No variation, no well it worked in dev surprises. Then there's version control. Your infrastructure becomes a text file you can check into Git, track every change, and roll back if something goes wrong. Automation comes next. You can plug these templates into a CI/CD pipeline and have deployments happen automatically. And finally, your template becomes living documentation. Anyone on your team can look at it and see exactly what resources exist and how they're configured. Here's the thing, ARM templates are idempotent. That's a fancy word meaning you can deploy the same template 100 times and get the same result. If the resources already exist, ARM makes sure they match the template. If they don't exist, it creates them. If something drifted out of configuration, it fixes it. Same result every single time. So that's the big idea. Now let's actually look at what one of these templates looks like. The anatomy of an ARM template. Every ARM template follows a standard structure with 6 main sections. Think of it like a recipe. You have your ingredients, your prep work, your cooking instructions, and finally the finished dish. Let's walk through each one. Schema. This is the first line of the template. It points to the JSON schema file that tells Azure what version of the template format you're using. You don't need to memorize it. Just copy the URL from Microsoft's documentation and paste it in. Azure uses it to validate your template's structure. Content version. This is your own version number for the template. Start with 1.0.0 and increment it whenever you make changes. It's useful when you're managing multiple versions of the same template across environments. Parameters. These are the inputs to your template, the values you provide when you deploy. Think of them as the ingredients you can swap out each time. You might have a parameter for the virtual machine size, another for the admin username, and another for the location. Parameters make your template flexible. You can use the exact same template to deploy a small, cheap VM for development and a large, powerful one for production. Just change the parameter values. Variables. These are values you define within the template itself. They're not inputs from the user. They're more like prep work, constructing naming conventions, combining strings, or calculating values that you'll reuse throughout the template. For example, you might define a variable that builds a resource name by combining a prefix and a parameter, so you don't have to repeat that logic everywhere. Resources. This is the heart of the template. It's where you define the actual Azure resources you want to create or update. Virtual machines, storage accounts, virtual networks, databases, whatever you need. Each resource has a type like Microsoft. Compute virtual machines, an API version, a name, a location, and configuration properties. This section can get long, but it's just a list of everything you want Azure to build. Outputs. After the deployment finishes, outputs return useful information back to you, like the public IP address of a new VM, a connection string for a database, or a resource ID you need for another tool. It's like the finished dish being presented to you. Here's the thing. At minimum, you only need 3 of these: schema, content version, and resources. Parameters, variables, and outputs are optional but incredibly useful. Most real-world templates use all 6. Let me show you the basic skeleton. At the top is the schema property pointing to the ARM schema, then content version set to 1.0.010, then an empty parameters section, an empty variables section, the resources array with your actual resources, and finally an output section. Every ARM template you'll ever see builds on this foundation. Now, once you understand the structure, the next question is how to make these templates work across different environments without rewriting them every time. Making templates reusable. The real power of ARM templates isn't just automating one deployment. It's using the same template for development, testing, staging, and production with minimal changes. That's reusability, and it's built into the template design. Parameterization is your primary tool. Instead of hard-coding values like the VM size or the storage account name, you define them as parameters. When you deploy, you provide a separate parameter file that contains the values for that specific environment. Your development parameter file might set the VM size to standard B2s, while your production file sets it to standard D8s or V3. The template stays the same. The parameter files change. Variables help you keep the template clean. Instead of repeating the same naming pattern in 50 places, define it once as a variable. If you need to change the naming convention later, you change it in one spot. Variables can also use template functions to combine strings, pick values from parameters, or do simple calculations. Conditions let you include or exclude resources based on a parameter. For example, you might want to deploy a Jumpbox VM only in production, not in dev. You add a condition that checks an environment parameter, and Azure skips that resource when the condition is false. One template, multiple scenarios. Copy loops let you deploy multiple instances of a resource without writing them all out individually. Need 5 storage accounts with the same configuration? Use a copy loop that iterates from 1 to 5 and creates each one. It's like a for loop for your infrastructure. Linked templates offer modularity. Instead of one massive template with everything, you break it into smaller pieces. One for networking, one for compute, one for storage, and link them together from a main template. This makes each piece easier to manage, test, and reuse independently. You can have a networking team maintain the network template and a compute team maintain the VM template, all composing together into a full deployment. The best practice is to treat your templates like application code. Store them in Git, version them, and integrate them into a CI/CD pipeline. Every time someone pushes a change, the pipeline validates the template, runs a what-if operation to preview changes, and then deploys it automatically. No manual steps, no forgotten updates. So now you know what a template looks like and how to make it reusable. The next piece is how you actually get Azure to run it. How deployment works. You've written your template, defined your parameters, set up your variables, and mapped out your resources. Now, how do you actually hand this to Azure and get it to build everything? You have 3 main options, and which one you pick depends on what you're trying to do. The Azure portal is the simplest way to get started. You upload your JSON file directly, fill in the parameter values in a clean web form, and click deploy. It's great for learning, testing, or one-off deployments where you don't need automation. You see a visual progress bar, watch each resource being created, and if something fails, the error messages are right there in the portal. But the portal isn't where ARM templates really shine. The real power shows up when you move to the command line. Azure CLI and PowerShell let you script your deployments and integrate them into CI/CD pipelines like Azure DevOps or GitHub Actions. Every time you push a change to your template, the pipeline can automatically validate it, deploy it, and tell you if something broke. No manual steps, no one forgetting to click the right button. You don't even need to install anything to try this. Azure Cloud Shell is a browser-based terminal that comes with both Azure CLI and PowerShell pre-installed. You're already logged in, so you can upload your template file, run a deployment command, and see the results, all from your browser. It's a great tool for experimenting without setting up a local environment. Before Azure creates any resources, it validates your template, it checks for syntax errors, missing properties, and incorrect parameter references. If something's wrong, it tells you before a single resource is created, saving you from those frustrating half-failed deployments where some resources got created and others didn't. Azure also has a feature called the what-if operation. You run it before deploying, and it shows you exactly what will change. Which resources will be created, modified, or deleted, like a dry run that shows the impact before anything actually happens. Once your deployment is done, Azure keeps a record. Every deployment is stored in the resource group's deployment history, so you can go back and see who deployed what, when, and what the template looked like. It's an audit trail for your infrastructure. Valuable for troubleshooting and compliance. But here's the thing, ARM templates are powerful, but JSON can be hard to read. All those brackets and curly braces make it verbose fast. And that's exactly why Microsoft created something better. The Bicep evolution. So what exactly is Bicep, and why should you care? Let's start with the old way. ARM templates have been around for years, and they're reliable. They power thousands of Azure deployments every day. But here's the problem, the JSON syntax is incredibly verbose. If you've ever opened a large ARM template, you know exactly what I mean. Pages of nested brackets and function calls that make your eyes glaze over. Microsoft looked at this mess and decided to build something better. Bicep is a new language. Technically speaking, it's a domain-specific language designed specifically for deploying Azure resources. The big idea here is that Bicep doesn't replace ARM. It compiles to ARM JSON. You write Bicep, and behind the scenes it gets converted into a standard ARM template, so you get all the power and reliability of ARM, but with a writing experience that's much cleaner. What does that actually look like in practice? Bicep cuts the code down dramatically. A template that needs 50 lines of JSON can often be written in just 15 lines of Bicep. It supports comments with a hash mark, uses string interpolation instead of those ugly concat functions, and the syntax is clean and straightforward. No more hunting for missing brackets. Bicep also has first-class modules. In ARM templates, reusing components meant dealing with linked templates and nested deployments, doable but complex. Bicep makes it simple. You create a module for a virtual network, another for a virtual machine, another for a database, and then compose them together like building blocks. It's modular, reusable, and easy to understand. Another big improvement is automatic dependency inference. In ARM templates, you had to explicitly declare depends on for every relationship. Miss one, and your deployment might fail because resources were created in the wrong order. Bicep looks at your code and figures out the dependencies on its own. One less thing to worry about. Microsoft now recommends Bicep for new deployments. It's fully production ready, covered by support plans, and has feature parity with ARM templates. If you're starting something new today, Bicep is the way to go. But here's why ARM templates still matter. Bicep compiles to ARM JSON, so when something goes wrong during deployment, the error messages you see are ARM error messages. When you look at the deployment history in the portal, you see the ARM template that was deployed. Understanding ARM, the structure, functions, and resource definitions, helps you troubleshoot when things go wrong. Bicep is the authoring tool. ARM is the engine. You need to understand both. So where do you start if you're completely new to all of this? Common mistakes and how to avoid them. Let me save you some headaches. The most common mistake people make with ARM templates comes down to simple JSON syntax. Missing a comma at the end of a line, forgetting a closing bracket, or putting a quote mark in the wrong place. These tiny errors can take forever to find when you're staring at a wall of JSON. The fix is easy. Use VS Code with the ARM Tools extension. It highlights syntax errors in real time so you catch them before you even try to deploy. Next up, typos in parameter names or variable references. You define a parameter called VM size, but somewhere in your template you reference parameters VM size, lowercase s instead of capital S. It won't match and the deployment will fail. The error message might not be crystal clear about why. The fix: stay consistent with your naming and let the VS Code extension catch mismatches. Then there's API version confusion. Every Azure resource type has different API versions and they change over time. If you're using an old version, you might be missing required properties. If you're using one that's too new, it might not be available in your region. The fix: Check the documentation for the resource type you're deploying and use the latest stable API version. Before you deploy anything, there's a command called AZ deployment group validate. This command checks your template for syntax errors, missing properties, and invalid references without actually creating any resources. Think of it as a safety net that catches most common mistakes. And if a deployment does fail, don't panic. Go to the deployment operations in the portal. Each operation shows you exactly what happened, with error codes and messages. 9 times out of 10, the error message tells you exactly what's wrong. You just need to read it. So here's the one thing I want you to remember above all else. So that's the system. ARM templates take Azure from a manual clicking exercise to something you can repeat and rely on. Start small, export a template from the portal, study how it's built, then tweak it. Subscribe for more plain English breakdowns and drop a comment. Let us know which resource you'd template first.